Space missions don't always go quite as planned, and by the time something goes wrong, your spacecraft is 100 million kilometers from home, too far away to dash out and repair it. Consequently, space science can get improvisational. If a tool is no longer capable of carrying out its original purpose, maybe it can still do something. Your adjustable wrench's threads are bound up? Now you've got a normal wrench. Oh, it's stuck closed entirely? Well, now you've got a very oddly shaped hammer. The folks at NASA have had to apply this school of thought to far more sophisticated equipment, and sometimes it works out really well for them. Here are just a few examples. The Hubble Space Telescope has been serviced by astronauts 5 times since 1990, but it's the exception. Because it's in low Earth orbit, we've actually been able to go there and fix it. Other telescopes are less lucky. The Kepler Space Telescope was meant to find exoplanets by continually watching faraway stars for transit events, a slight dimming of a star's brightness for a specific amount of time, indicating that a planet is passing in front of it. Through this method, Kepler aimed to identify as many Earth-sized exoplanets as possible, while looking at a patch of about 150,000 stars. It had 4 gyroscopic stabilizers, one stabilizer for each 3-dimensional axis, plus a spare if one of them should fail. These were to protect the probe from being pushed around too much by pressure from the solar wind. In 2013, 4 years into the mission, 2 of the stabilizers had failed, which made it too hard to keep the telescope steady. So NASA put it into sleep mode and went back to the drawing board. After a few months of hard work, scientists realized they could use the solar wind instead of fighting it, basically bracing the spacecraft against it and using the other 2 gyros to keep it in place. It would mean they'd need to realign the telescope every 80 days as it orbited the sun and slowly shifted its angle relative to the solar wind, which meant pointing it at a new field of stars every few months instead of studying the same patch continuously. But these limited campaigns returned fantastic results and buckets of exoplanets for researchers here at home. And this isn't the only telescope NASA's had to save. Spitzer is an infrared space telescope designed to operate slightly above absolute zero to see distant objects that optical telescopes can't, such as low-temperature and dim objects far away. Spitzer initially had a life expectancy of 2.5 years, which it easily outstripped. But in 2009, after 5.5 years of operating, its liquid helium coolant finally ran out. Spitzer could no longer look at some of the very cool and dim objects it had been designed to spot. But at its new temperature, the telescope could still look at asteroids and comets in our own solar system, as well as far-off ancient galaxies. This was the start of its so-called warm mission, which at minus 241 degrees was still pretty chilly. As a result of this repurposing, Spitzer has subsequently observed countless amazing objects in our own solar system, and it's expected to keep going into 2020. But space missions obviously aren't all about looking at things from afar. Sometimes we want to get up close and personal. To that end, the Deep Impact mission was designed to slam a probe into a comet while the probe's mothership watched. In 2005, the 370-kilogram impactor probe successfully smashed into Comet Tempel 1 at 37,000 kilometers per hour, and in doing so, revealed a lot about the nature of comets. The mission was complete, but while the probe had very much crash-landed, there was still a perfectly functional mothership out there. So mission managers sent it to do more cool comet science elsewhere. During its new mission dubbed Epoxy, the probe flew by another comet, made observations of Earth and Mars, and even searched for exoplanets. Eventually, though, NASA lost contact in August 2013. Then there's the part where NASA used a totally different probe to get more mileage out of Deep Impact's results. The Stardust spacecraft, which flew through the tail of Comet Wild 2 in 2004, was similarly successful enough to be given new tasks. One of these was a flyby of Tempel 1. Stardust's visit in 2011 gave NASA the opportunity to observe their handiwork and to make further observations of the unfortunate comet. And while we've covered it before, no discussion of spacecraft doing more than their planned workload would be complete without a mention of the Mars rover Opportunity. Oppie lasted 60 times longer than its planned lifetime of 90 days, spending nearly 15 years searching for signs of water and collecting other data on the red planet. Opportunity is a pretty extreme example, but its success speaks to the careful planning and engineering that goes into every device we launch into space. Space travel is difficult and expensive, so the scientists responsible for it really care about getting it right. Whether it's coming up with clever fixes from afar or just making the most of their funding, scientists have gotten pretty adept at getting everything they can out of their outer space investments. Thanks for watching this episode of SciShow Space. This episode, along with every other episode we make, was supported by our patrons on Patreon. If you're interested in helping us with what we do, check out patreon.com/SciShow.